So welcome to session 7. This session is about public goods, and we have actually 3 presenters today. And our session lasts for 100 minutes in total, and each presenter then has 30 minutes for the talk, and maybe 5 additional minutes for Q&A. I would remind each presenter when there is only 5 minutes left for his or her talk. And so maybe we should just go to the talk today. And the first presenter today is Fenqi Guo from University of Zurich. And she'll be giving a talk on evaluation on individuals versus evaluation on groups, evidence from a public goods experiment. And let's welcome.
Hello, everyone. I'm Fenqi Guo from University of Zurich. This is a joint work with Yunwen He and Professor Jie Zheng from Tsinghua University. The title of our research is Evaluation on Individuals versus Evaluation on Groups, Evidence from a Public Goods Game Experiment. Our research question is just as the title suggests. We want to know in public goods games with peer approval, how does evaluation on individuals interact with and differ from evaluation on groups? For example, in a course I took last year, the professor asked us not only to evaluate the effort my teammates put into the group work, but also the quality of work produced by other groups. So this assessment method actually consists of 2 evaluation modes. How can these 2 kinds of evaluation influence the contribution amount, and what is the mechanism behind that? We categorize the research on PGG with non-monetary incentives into 3 parts: peer pressure or social information, social comparison or social competition, social approval and disapproval. Our research focuses on the last category, social approval. Previous studies in this field suggest that the voluntary cooperative behavior in PGG may be driven by social recognition or emotional activities. Hollander, 1990, theoretically proposed that individual behavior will be affected by the evaluation of others. Rigid, 2004, viewed social recognition as a commodity, equivalent to private consumption and public goods. In PGG experiments, social recognition generally takes the form of after-contribution evaluation. Group members get to know each other's contribution and score each other. For example, Maslad et al. 2003 asked participants to assign disapproval values after contribution and found this non-monetary penalty has a robust effect. Dowger 2013 compared social approval positive scoring and disapproval negative scoring, and found that the latter one can produce higher contribution. Pan and Hauser 2017 concluded that when rewards are unique and sustainable, competition for peer approval leads to the highest contribution. In summary, existing literature, including both theoretical and experimental researches, mainly considers the in-group social factors, that is, the evaluation on individuals, that does not take into account cross-group factors, that is, evaluation on groups, which we think in real-life public goods games also play important roles. Referring to the experiment of Dowger, 2013, we introduced evaluation on groups to examine how groups react to evaluations in PGG and how this can promote or influence contribution. Here lists our highlights of our research findings, which we regard as significant and innovative. The main determinant of evaluation is the deviation of the assessed individuals or groups' contribution from the average. The individual evaluation, based on contributions in the current period, can significantly promote contribution in the next period, with a higher disapproval score leading to an increase in the next period's contribution. But the evaluation on groups has no such effect. However, Having the groups evaluated before the individual stage can strengthen the effect of disapproval on individuals, thereby indirectly affecting the cooperation level. So let's move on to the experimental design. Our experiment includes 2-dimension 6 treatments. Control setup, no evaluation, denoted by C. Individual disapproval, I. Group disapproval, G. First group then individual disapproval, GI. First individual then group disapproval, IG. Simultaneous individual and group disapproval, I and G. We used 6 settings, among them 3 settings that includes both evaluation on individuals and evaluation on groups. Why? That is because we think the order of evaluation may affect scoring or contribution. For evaluation on individuals after knowing the cross-group evaluation result, external evaluation on groups may affect internal evaluation on individuals, which is the external to internal effect. And similarly, for evaluation on groups after knowing the in-group evaluation result, there may exist internal to external effect. Our experiment consists of 12 sessions, 2 sessions under each setting, each with 10 periods fixed matching PGG, and has 16 participants. The control group only has the contribution stage. In all 5 experimental groups, each period includes a contribution stage that occurs first and a disapproval evaluation stage that occurs later. We use disapproval to denote social evaluation. Although social disapproval as a measure of sanction may reduce economic efficiency or cause retaliation, existing literature generally shows that punishments are more effective than rewards. For example, Dogger 2013 in non-monetary circumstances. Our experiment was conducted by Z-Tree. The contribution stage is similar to the standard public goods games. In this stage, participants attended PGG experiments at a fixed group of 4. At the beginning of each period, all participants receive 20 game coins. Then they simultaneously choose the amount of coins they make to the public account, which is called the contribution amount. The parameter of our experiment is very similar to that of Maslach et al. 2003 and Dogger 2013. And here we list the payoff function. As mentioned above, there is no disapproval evaluation stage in the control group, but this stage is included in all other 5 experimental groups. In this stage, participants obtain information regarding the contribution of other members in this group or other groups in this session. They can then assign disapproval scores to express the extent to which they are unsatisfied with the contribution decisions of others. Here is a flow chart. This figure shows the procedure and information structure in each stage. For example, in Group GI, after contribution stage, participants first know the public good amounts of all 4 groups in this session and evaluate other 3 groups. Then they learn the disapproval score received by each group. Later, they are shown to the contribution made by each member in their own group and evaluate other 3 individuals. Then they learn the disapproval score received by each other member. The evaluation does not bring any cost, and the disapproval score can be any integer between 0 and 6, with 0 indicating the lowest disapproval and 6 indicating the highest disapproval. All disapproval decisions are made at the same time, and everyone cannot make the evaluations to themselves. Although each participant in the 5 experimental groups can see the contribution levels and scores of other people and other groups, we believe such design does not constitute competition within or between groups, because obtaining a lower relative disapproval point does not bring about a final material reward, which is different from the experiment of Pan and Hauser, 2017. Furthermore, each person's disapproval value is non-competitive. A member obtaining a higher disapproval does not necessarily mean that other members must obtain a lower disapproval. Therefore, we think it is reasonable to attribute the difference between the contribution levels to the difference in disapproval evaluation mechanism rather than the level of competition. Here we made 6 predictions before the experiment based on literature in behavioral economics and social psychology. Due to time limit, I cannot deliberate them in detail, but I will compare them with corresponding results in the following pages. Here is our result 1, our overall prediction and the result of average contribution. This figure shows the time series of each treatment's contribution. In the first period before the disapproval evaluation, the contribution under all 6 treatments are similar. In the subsequent periods, however, the average contribution of Group C continued to decline, but Group IG, Group I, and Group GI reached and maintained high level of contribution. It can be seen that the order of evaluation on groups and the evaluation on individuals matters. The treatments with successive evaluations has higher contribution than that with simultaneous evaluations. Moreover, evaluation on individuals alone can lead to higher contribution than evaluation on groups alone. This is our Mann-Whitney rank sum test. So combining this two-sided test result and independent sample test, the relationship among the 6 treatments can be inferred as stated here. Moving on to the result 2. This result confirms both our prediction 2A and 2B. That is, the average contribution of Group C is lower than that of Group I, but the average contribution of Group C is not significantly differs from that of Group G. So why is this the case? Rich literature have proven that evaluation on individuals does promote contribution, but for evaluation on groups, scholars actually have different opinions. For example, social psychologists such as Brewer and Kramer, 1986, argued that by establishing a collective identity through evaluation on groups, members will regard the 4-person group as a whole, so individuals' contribution will increase. However, behavioral economics like Boyd and Richardson, 1992, pointed out that to make the evaluation effective, the penalty or sanction must be pointed to a specific individual. However, in the evaluation on groups, the penalty was pointed to a group of 4 people, but not one single person, so it will not increase the contribution. Our analysis also focus on why social psychology theories do not work here. We think that's because if we want this theories to take into effect, then we first need to establish collective identities. In experiments, however, collective identities may not be fully established, which may be due to a variety of reasons such as evaluation systems or decision periods too short, or maybe our experiment instruction does not clearly state the concept of collective identity. So therefore, in Group G, participants may not form a connection between disapproval on groups and individual emotions. This is our third prediction and result. The regression shows that evaluation order affects evaluation results, that is, the contribution of public goods. Successive evaluation is better than the simultaneous evaluation. As can be seen here also, sequence IG is not significant, while sequence GI is significant. This analysis also supported our result 1. Next, prediction and result. We think it is also important to understand the determinants of negative evaluations. In the 5 experimental groups, when the participants evaluate others, they have observed the contribution decisions of other members or other groups, so they make disapproval evaluation based on this information. Here we predict that both the deviation from the average and from the own value influence the rating behavior. The result, however, only proves that the deviation from average matters. Although the correlation coefficient is significantly negative, The higher scatter plot here, which is the evaluation on individuals, does not clearly reflect this trend, especially that when the contribution amount is 10 and 15, the disapproval score ranges from the lowest 0 point to the highest 18 points, which implies that in addition to the absolute contribution amount, reference points also affects the evaluation. Therefore, we conducted 5 regression analyses to study participants' evaluation behavior. In each regression model, the dependent variable is the disapproval score made by participant A to participant B in period T. And explaining variables include the deviation of contribution from myself or my group, and from this group average or this session average. We found that although background information and other variables affect the disapproval score made by participants in each setting more or less, only the correlation between deviation from the average and the disapproval is stably negative. This is also confirmed by these 2 scatter plots. The negative linear correlation shown here in the scatter plots is more obvious than that in the previous 2 figures. Also, in the GI evaluation mode, the disapproval received by the group will be passed on to members in the individual evaluation stage, as can be seen from the regression result here. However, in the IG evaluation mode, the disapproval received by individuals will not be passed on to other groups in the evaluation on groups stage. In other words, the group evaluation conducted first can strengthen the individual evaluation conducted later. This is confirmed by the regression analysis and corresponds to one of our prediction, that is 5A. Finally, we used regression analysis to study how disapproval scores received by participants in period T-1 can change their contribution behavior in period T. I put the 5 regression results in the appendix pages. The regression results shows that in the 4 treatments involving evaluation on individuals, the individual disapproval received in period T-1 significantly increased the participant's contribution in period T. That is, if the participant in the previous period receives a high disapproval score, this period he will increase contribution. On the contrary, in treatments with evaluation on groups, the group disapproval received in period T-1 does not change contribution behavior in period T significantly. One exception is in group IG, which evaluation on groups even has a significant negative effect. That means when a person or group receives a high disapproval in period T-1, then in period T, they will contribute even less. Here, I want to deliberate more on the average contribution rank and make a speculation on the reasons for that. The 2 relationship here in blue is quite easy to understand, as we have shown that evaluation on groups does not significantly increase future contributions, so its effect is negligible. As for the third one in red, group I and G regression indicates a significant negative effect of evaluation on groups. This counter effect offsets the positive effect of evaluation on individuals and makes the average contribution in group I and G similar to that of group C. Moving on to the last one here in red, results 5 reveals that in group G, in treatment GI, the disapproval score received by the group will be passed on to members in the individual evaluation stage, which does not in treatment IG. Hence, the evaluation on groups conducted first can strengthen the evaluation on individuals conducted later and increase the disapproval to free riders. Therefore, with other conditions the same, the disapproval to free riders in group GI will be higher than that in the other 2 groups, group GI and group IG. There are further strengthening effects in group GI. The same personal evaluation result can produce the highest contribution increase in this setting, as shown by the regression results. Therefore, we conclude that group IG more than group I is attributed to the combined effect of two factors. On the one hand, participants have disapproval on groups passed on to disapproval on individuals, resulting in higher disapproval scores received by free riders, which strengthens the disapproval on individuals. On the other hand, one unit disapproval on individuals in the previous period has the strongest influence on the contribution increase in the next period in setting GI. Hence, the average contribution of group GI is higher than that on group I and group IG. So let's make a short conclusion. To improve the social efficiency in public goods games, we innovatively introduced an evaluation system with disapproval on groups in the experiment as a supplement to the disapproval on individuals, which has been proven effective, so as to explore how groups react to evaluations. According to the evaluation type and order, our system consists of 6 settings. We conclude that group evaluation itself has no significant effect on the individual's contribution behavior towards public goods, but having the groups evaluated before the individual evaluation can strengthen the effect of individual disapproval, thereby indirectly affecting the cooperation level. However, our research still has some limitations. For instance, we do not know whether the influence of collective evaluations exists in other cultures, because Chinese students may be particularly sensitive to collective feedback. And also, our experiment raises a series of new questions. The most relevant issues for evaluation on groups include how to allow participants to establish a strong collective identity in the public goods game experiment, so as to improve the effect of evaluation on groups. It is also worth noting that in real life, people expressing disapproval towards their peers may take time and energy, but in the experiment setting, evaluation bears no cost. Therefore, it's important to study evaluation with cost. How can it affect cooperation? So that's the end of my talk, and I'm open to questions now. Thank you.
So thank you, Fenqi, for your clear and very well-organized presentation. And so everyone, please feel free to raise your questions or leave comments. Well, you may still give your questions or comments after the next talk or when we finish this session. So we can now go to the second talk by Professor Michalis Druvelis from University of Birmingham. And he will be giving a talk on social framing facts and leadership preferences or beliefs. And that's welcome, Professor Druvelis.
Hi, everyone, and thank you very much for your kind introduction. Good morning from Birmingham. I hope you are all doing fine and staying healthy and productive during these challenging times. Today, I'm going to present a joint work with Edward Cartwright, the title of which is Social Framing Effects in Leadership, Preferences or Beliefs. So I would be very happy to get your feedback, and if you have any questions during my presentation, feel free to interrupt and ask any questions you might have. So let's get started with some brief motivation about our work. So we are building on the extensive literature, experimental literature, role of leadership in public good games. There is significant evidence in economics trying to understand whether leadership can be an effective means in increasing cooperation. The existing results so far are mixed, so there's little evidence leadership by itself can increase efficiency, but under some conditions, leadership does increase efficiency substantially. For example, if leaders are endogenously determined, or if they have higher status, or if leaders are exclusion rights, then it is the case that indeed leadership is efficient. all hear me because I get a message that my internet connection is unstable. So if there is any problem, just give me a shout.
It's fine. It's
It's
fine.
fine. Perfect. Thank you. So why do we observe these results in the literature? So there are basically two explanations suggesting that either leaders do not set a good enough examples or followers are less reciprocal than one might expect of conditional cooperation. Okay, so if these two conditions happen, then we observe that leadership is not as effective. So in our experiment, we're trying to understand this further, and we're basically asking whether there is anything to increase the effectiveness of leadership, either by influencing leaders to set a good example or followers to reciprocate. And we try to understand basically can change either of these two factors. Now, in terms of framing, we're interested in two dimensions. First of all, we are manipulating the individual level framing. So in identifying how the players are called in the game. So we use a leader versus first mover manipulation. And we're also varying the group level framing by either calling the game a community game or a Wall Street game. So in motivating our choices of in terms of the individual level framing, there is no study that we're aware that has directly compared the term used to identify. So most of economics experiments use neutral wordings for this, for identifying players in the instructions. So these early contributors or first movers. The word leaders is very rare. There are a few psychological studies that use the word leaders to identify players, but none of these studies make a comparison across frames. We think this is an interesting framing because this can make actually the leaders more aware their contribution has or may have on the contributions of others. Now, regarding the comparison of the group that we are using, the community versus Wall Street, then this has been explored previously by other economic experiments. Closer to our study are a couple of experiments by Duffenberg et al. And Elliksen. So the Duffenberg et al. Experiments uses the community framing and finds marginally lower contributions in that frame. There is also by Reger and Telek, which finds basically higher contributions in the community frame. The Elliksen find that cooperation was higher in a community frame when compared to the stock market frame. This choice was simultaneous. The same with Duffenberg et al. Experiment. They choose a simultaneous public good game experiment to study cooperative behavior. For the Elliksen, the framing vanishes when the game was played sequentially. Now, the reason why, there is also another very nice study by Frankenpol et al., which also study framing in leadership, but they consider a give versus take framing. And they actually find that the give frame contributions are higher. The reason why I'm saying that Duffenberg et al. And Elliksen et al. Are closer to our study is that these studies focus on the role of beliefs, and the role of beliefs is also very crucial in our experiment. So we hypothesize in our study that if there are any framing effects, so these framing effects are driven by changes in belief rather than social preferences. Okay, so for example, it is the frame that influences beliefs, which then influence behavior, which would be consonant with the line of thinking as reported in the Duffenberg et al. Study. So before I go to the experimental, let me first give you a very brief outline of the findings that were reporting in this experiment. First of all, we find higher contributions in the Wall Street than in the community frame. That's particularly the case with the first mover individual frame. There is no difference in the individual when we compare behavior across the individual level frames. So the first finding is in line with the Duffenberg et al. Study to find lower contributions in their community frame, but they have simultaneous choice. Crucially, and more importantly, which is also the bottom line, the main message from this paper, crucially, this effect is explained by changes in first order and second order beliefs. And in particular, these findings reinforce the message of the Duffenberg et al. And Ellingsen et al. Experiment on the mediating role. So let me now, if there are no questions so far, let me move on to the experimental design. The main framework that we are using in this experiment is a 3-player sequential public good game. So that's a repeated game where participants play 10 rounds in total, and we implemented a partners matching protocol. So the partner matching protocol means that the group composition remains the same throughout the experiment. Now, for a given player, the payoff function is as follows. 20 is the endowment given to each player, minus CI is a contribution made by a given player to public good. So 20 minus CI is the income from the individual account. And we add to that the income stemming from any in the public account. So the income from the public account is equal to 0.5 multiplied by the total sum of contributions made by all 3 players. So that was a payoff functions. We have a sequential structure in the sense that there is one leader that moves first and how much to contribute to the public good. And following the leader's contribution, this is announced to the followers. So the followers know how much the leader has contributed first in the public good game. And the followers, the 2 followers that we have to decide simultaneously contribute to the public good. So that was the structure of the game for a given period, and that was repeated for 10 periods. Now, because we would like to gain a better understanding on individuals' behavior, we're also eliciting incentivized beliefs about others' contributions. So when the leaders decide how much to contribute, then the followers are being asked to state their first or second order beliefs. And at the same time, when the followers are making their contributions, we ask the leaders to indicate their first order and second order beliefs. So the first order beliefs relate to leaders' beliefs about the amount followers would contribute, and they do so when the followers are contributing to the public good. The follower beliefs are about the amount the leaders would contribute, and the followers, as I mentioned before, decide on how much to contribute when the leaders make their contributions. On top of considering first order beliefs, we also ask individuals to indicate their second order beliefs. So these are basically leaders' beliefs about the first order beliefs, and similarly, followers' beliefs about the leaders' first order beliefs. Okay, so we have data on contributions, first order and second order beliefs. And we try to explain basically how frame influences behavior, and in particular, the mediating effects of beliefs. Now, in total, we have 4 treatments, so that's a fully crossed 2x2 between subject design, so no subject experience more than 1 treatment. We have 2 group level frames and 2 frames. The group level frame referred to Wall Street experiment versus community experiment, so the group level refers to how the game was called in the instructions, so either community or Wall Street. The individual level frame has to do with how the players were identified in the instructions, So it could be that in one framing condition we have leaders, which is a more loaded use of identifying players, and the other type of framing that we had to identify players was either first or second mover, which is a more neutral wording previously used in other public good game experiments. There are 4 treatments: community first mover, community leader, Wall Street first mover, Wall Street leader. In each treatment, we collected 72 observations. That was a partners matching protocol. Each group had 3 group members, so the total of independent observations per treatment is equal to 24. Now, our procedures, and then move on to our hypothesis, are standard. So in total, we had 288 subjects. The experiment was a lab experiment. We managed to run this experiment in winter 2019, in November, if I remember correctly. So it was still run physical lab experiments at that time. And we ran it in the Experimental Economics Laboratory at the University. That's a between subject design. No subject participated in more than one session. And in total, we had sessions lasting on average for approximately 50 minutes. Average earnings were £11.55. So let me move, unless there are no questions for the design, let me move on to the hypothesis that we're making for this experiment. If subject's objective was just to their own payoff, then the uniqueness equilibrium would be that there would be no contribution, so everybody would keep their initial endowment. Now there is extensive literature in public good games indicating that to some extent individuals are willing to contribute. Relying on this literature, we also expect that individuals to some extent will contribute, and also with regards to leadership literature, there might be 2 explanations why individuals do so. One, we refer to this as coordination, the other is strategic leadership. So there is evidence that people are willing to conditionally cooperate in public good game. Approximately 50 to 70% of individuals can be classified as conditional cooperators, in that individuals are willing to cooperate if others do cooperate, or if they expect others to cooperate. Now, such conditional cooperation can turn the public good game into a coordination game. And then our interest is that labeling can have an influence in coordination games by directing attention from one equilibrium to another. As a result, this may influence first, second, and higher order beliefs. Most relevant to our experiment is the Elixen et al. Study, which finds that cooperation is higher in the community than in the stock market frame in the simultaneous prisoner's dilemma game they have. And importantly, crucially, to the results, they find that frames change beliefs, not because it changes social preferences. So the Elixen et al. Paper refers to this finding as the coordination hypothesis. So we also expect that the contribution of the leader, in our case, in the Elixen et al. Paper, there are 2 players, and this resolves the uncertainty. We have 3 players, 1 leader and 2 followers. Still, in this case, we expect that the contribution of the leader provides an unambiguous focal point for followers. So conditional on the contribution of the leader, there are no difference in the contribution of followers. So that would be our first hypothesis. This does not imply that there are no treatment differences at all, but what this hypothesis simply says is that any treatment difference must come through a change in contribution of the leader. So controlling, conditional on the leader's contribution, we expect to find no treatment differences in the follows. That's hypothesis number one. We then we turn on the second hypothesis, which basically says that we already know that leaders' contribution are crucial in the public good game, so that's not news. So if a leader does not set a good example, then it is no surprise that leadership will have a mixed contributions. Now, in this experiment, our experimental design allows us to understand better how framing can influence beliefs and can influence the contribution, in particular, the contribution of leaders. And there are various channels for potential channels for this effect. One effect is to frame the name of the leaders by calling the players as the first movers as leaders. This may make them more aware about the influence they can have on others' contributions, or by using a community framing, this may also influence potentially internalized social norms. Now here we don't make a priori any predictions on how framing may influence the leader's behavior. As I said, there are experiments finding that the community frame increases contributions, other experiments finding that the community frame does not increase, actually reduces contributions. So we don't make predictions on how framing may influence the leader's contribution, but we hypothesize that the frames may influence the leader's contribution, and in particular, any change in leaders' behavior is mediated by a change in beliefs. So our second hypothesis is that the contribution of the leader is increasing in first and second order beliefs. Okay, so first hypothesis, conditional on the leader contribution, there are no treatment differences for the contribution of the followers. And second hypothesis, the contribution of the leader is increasing in first and second order belief. I'll now move to the result. First, let's have a look at the overall contributions across treatments. So this pooling leaders and followers contributions. In the next slides, I will split and we'll see how contributions of the leaders separately are affected by our framing manipulations. So in this graph, we can see the average contributions across treatments as a function of the period. We have in total 4 periods. There are 4 lines that you can see in this graph. The community leader treatment are indicated with the black and the red line respectively. So we can see that for these 2 framing manipulations, the lines are very close together, implying basically that for given community, manipulation between the first mover and the leader does not yield any significant differences. The same conclusion is obtained when we look at the Wall Street first mover versus the Wall Street leader treatment. That's indicated with the green and the blue lines respectively. Again, you can see that these 2 lines overlap with each other. So again, the first mover versus the leader framing does not make any difference, does not affect behavior significantly. What does make a difference is a group level manipulation. And in particular, you can see that the Wall Street manipulation indicated by either the blue and the green lines are significantly higher compared to the red and the black line, which corresponds to the community leader and community first respectively. This difference appears to be more significant in the second half of the game, where we can observe that there is a slight decrease in contributions for the community frame. Now, moving to the leaders' contributions, again, that's exactly the same that we have seen before. So the interpretation of the figure is the same as in the previous slide, but now the difference is that we are focusing only on the lead contributions. Again, the main message from this graph is exactly the same as before. So there are no treatment differences for the first mover versus leader manipulation that we have. The treatment differences stem from the community versus Wall Street manipulations, and in particular, leaders in the Wall Street experiment contribute significantly more than leaders in the community experiment. So let's now test these results, and in particular see if we can find evidence for hypothesis 2 in this regression by looking at whether there are treatment differences in leaders' contributions. How much time I have if you show me the amount of, how am I doing time-wise? Am I okay?
It's okay, you still have time.
Fantastic.
Until 11.
Excellent, thank you so much. So we're looking at, in the first model of this regression analysis, we're looking at the leader's contribution as a dependent variable. So that is a top-bit regression that is actually, the reason for that is that the dependent variable is at 0 and 20. The first model indicates there are significant treatment differences in the leader's contribution, in the confirming basically what we have already seen in the previous graph. The baseline category here is the Wall Street first mover. So we have three dummies: first mover, community leader, and Wall Street leader. So the baseline category is a Wall Street first mover. We can see that the community first mover and the community leader are significant. The coefficients of these two dummy variables are significant and negative, and with what we have seen already in the previous slide. Now, in the second model, when we augment this model by including the leader's first order beliefs and the leader's second order beliefs, first we observe that the treatment differences disappear. So the community treatment dummy and the community leader treatment dummy are not anymore significant, and leader's first order beliefs and leader's second order beliefs positively correlated with the leader's contributions, which provides support for our second hypothesis. Contribution is increasing in first order and second order beliefs. Now we then explain and discuss how the followers' behavior depend across our treatments. Again, we plot average contributions over time across our four treatments. The message again here is the same. We don't find any difference between the mover and the leader manipulation, either when we look at the community frames or at the Wall Street frames. However, treatment differences stem from the group level framing. Again, in the Wall Street frame, followers on average are more to contribute compared to the community frame. Now, regression results for the followers' behavior. Here, 4 different regressions. The dependent variable across all 4 different regression models correspond to the followers' contributions, and this varies from 0 to 20. So that's again a top-bit regression that we are using here. Again, we have 3 dummy variables, and as before, the dummy variable that is the baseline corresponds to the Wall Street individual. In the first model, we only for the 3 dummy variables, and we find that there are treatment differences as shown in the previous graph, in which frame first mover treatment yields lower contributions compared to the Wall Street first mover treatment. So there is a difference between the community and the Wall Street And this difference is particularly salient and significant for the first manipulation. Now in the second model, when we include the leader's contribution, and in the third model, when we include separately the followers' first order beliefs and the followers' second order beliefs, we observe that differences as documented in the first regression model disappear. And in particular, the followers' contribution is positively correlated with the leader's contribution. That is, when the leaders contribute more, the followers also contribute more. There's a positive correlation between these two. And there is also a positive correlation the followers' first order beliefs and second order beliefs and the followers' contribution. In the fourth model, when we include these three independent variables, leaders, followers, and first order beliefs and followers' second order beliefs, we obtain a similar picture, no treatment differences. Overall, these regression results provide strong support for hypothesis 1, which indicates that conditional on the leader's contribution, the leader's contribution is, in our case, because the leaders provide a clear and unambiguous focal point for their followers. So conditional on the leader's contribution, we observe no treatment difference. The treatment differences that we observe are disappearing. So this is the main message from our experiment, and here I will repeat the conclusions from the results. We find a significant effect of the group level. In particular, the community experiment, we observe lower contributions in the community experiment, particularly with the first mover, in no significant effect of the individual level frame on either the leader or the follower contributions, and in line with previous results as reported in the Duffenberg et al. Study and in the Elixen et al. Study, we find that the framing effect is driven by changes in first and second order beliefs. So I would like to thank you very much for joining and watching this presentation, and I would appreciate if you have any feedback or any questions. If not, you can feel free to email either Edward or myself and ask any questions. Thank you so much for your attention.
Thank you, Professor Tivelis. If anyone have questions or comments, you can just
I see Todd Kaplan has raised his hand. That's what my screen says. So I would be very happy to question by Todd.
Yeah, thanks. I was just, the beliefs you elicit are how much someone would contribute, correct?
So the beliefs we elicit are exactly, yes, how much they contribute. We have first order and second order beliefs. So this is first order beliefs about the amount followers would contribute, followers beliefs about the amount leaders would contribute, and the same for the second order beliefs.
Yes, so, but I think that the beliefs, at least for the leader, some of the beliefs that's important is sort of contingent. So if I contribute, you know, maybe I think they'll contribute a lot, but whatever I do, it's not going to have an influence on them. So I think a lot of the beliefs that matter is if I increase my contribution as a leader, will others follow me? I think that's sort of the beliefs we might be looking at, which it doesn't look like you took.
No, well, when the leaders contribute, the followers decide on their contribution. When the followers contribute, they have already stated their beliefs while the leaders are contributing, if that's the question you're asking.
Yeah, but when you ask the leaders' beliefs, it's, you know, sort of before the followers make a contribution. And so what I thought is you might want to ask, well, if I contribute, say, 2, how much do I think the followers would contribute, as opposed to if I contribute 10, how much do I, you know, so for every dollar I contribute, how much do you think the followers are going to increase the contribution, rather than how much they're going to do?
Why would that make a difference? I mean, in the way that we're doing it is in a similar way, right?
I think you're just saying how much you think they're going to contribute, but it's not contingent upon how much I contribute, right?
No, how much?
We'll talk maybe afterwards, okay?
Right. Yeah, okay. Email me, Jody. Yes, exactly. Okay. Let me think about that. I'm not seeing this,
Yeah.
how it's very different, how it would make a huge difference from what we are doing, but I may miss something now.
Yeah. Okay.
Thank you anyway.
Yeah.
So I'm Rongrong Fu, last presenter of this session, and I'm a master student from Humboldt University of Berlin, and I'm about to start my PhD program this fall. And I will be giving a talk on alternative assurance payment schemes in threshold public goods provision. It is an experimental investigation, and it is a co-work with Professor Zhi Li from Xiamen University, China. Here is the layout of my presentation today. I will first give you some motivation of our research and briefly introduce the theoretical models and our experimental designs. Then I'll explain the major findings of our experiments and then draw a conclusion. So throughout the literature, there have been many mechanisms designed to deal with the free riding problems in public goods games, just like what the previous presenters have presented. And there are mechanisms that improve provision rates of discrete threshold public goods, which we're really interested in, since the crowdfunding is really popular these days, and but the provision rates of public goods in this kind of crowdfundings are not really satisfactory. So among these mechanisms, we mainly focus on a branch of assurance payment schemes that encourage commitments to contribute by offering assurance payments, or say rewards, to potential contributors when the group fails to provide the public good. And a mechanism called provision point mechanism, PPM, serves as our baseline model. In provision point mechanism, when a group of agents contributes toward a public good, if the threshold is not met, the public good is not provided. And each agent gets his own contribution back, and so there's money back guarantee. But if the group contribution reaches the provision point, or say the provision threshold, he will enjoy the valuation, his individual valuation of the public good. So his payout would be the valuation minus his individual contribution. But there are two problems with this kind of provision point mechanism. The first problem is that it does not eliminate non-provision from the set of equilibria. And the second problem is that even in provision equilibria, there is a continuum of equilibria, which may cause the equilibrium selection problem. So in 1998, Tabarrok proposed a so-called dominant assurance contract mechanism, which is theoretically proved to eliminate non-provision in equilibria, and especially in complete information setups, there is unique provision equilibrium. And DAC is actually a take it or leave it offer, which includes a predetermined contribution for provision, and also a minimum number of acceptance needed for the public good to be provided. It also specifies a fixed level of assurance eligible to acceptors when the public good is not provided. And also in by this experiment, this theoretical model has not been tested by experiments. So in 2014, Li et al. Actually proposed a mechanism called assurance payment mechanism, which is somehow a modification from DAC. But it allows for continuous contribution instead of a fixed level of contribution. But otherwise, they are theoretically equivalent. So APM pays a predetermined assurance payment once a minimum level of individual contribution is reached when the public good is not provided. And in 2017, Kaysen and Zubrikas proposed a refund bonus mechanism, which rewards contributors proportional to their contributions. It is also a modification of DAC, and it also allows for flexible contribution, but there is no minimum individual payment level required in order to get this kind of refund bonus when the public good is not provided. Experiments have been done for the latter two mechanisms, IPM and RBN, and they both claim to have increased provision rates of the public goods compared with the baseline model PPM. So with all those models at hand, we were then curious about how these theoretically equivalent mechanisms differ in promoting provision rates and group contributions, and whether they perform very differently when the characteristics of agents in a group vary. And by the characteristic here, we are mainly addressing whether the agents are homogeneous or heterogeneous regarding their individual induced value of the public good. And if these kind of this assurance payment schemes differs in inducing provision rates, through which channels do they differ? And finally, we also would like to give some hints on social welfare that is generated by these mechanisms and their feasibility. So before we go to the experiments, I would first introduce the theoretical models proposed in previous literatures. The first is the baseline model, the provision point mechanism. Since these models have already been explained in detail in their relative papers, I would only give you some intuitions of how they incentivize individual contributions and by introducing the individual payoff functions. So in provision point mechanism, when the group contribution reaches the provision threshold, each agent will get his own valuation of the public good minus his individual contribution in addition to his endowment. Otherwise, he does not get anything in addition to the endowment. So in equilibrium, in the non-provision equilibrium, when all agents contribute 0, no one would deviate to contribute since no one can singly fund the public good. So PPM does not eliminate non-provision. But in the first assurance payment scheme, the DAC mechanism, we can first look at the individual payoff function. When the total number in a group of acceptors reaches a set K, which is determined by the contract, and if agent I accepts the contract, which is represented by MI equals to 1 here, he will have to pay the set contribution, but he will also get his individual valuation of the public good. But also in the case of provision, a rejecter of the contract doesn't have to pay the set amount of contribution. However, in the case of non-provision, where the number of acceptors falls short of the K, and acceptor will have will be eligible to the assurance payment here, represented by F, while the rejecter doesn't have the right to get this assurance payment. And in this case, when the public good is not provided, a rejecter would love to deviate to be an acceptor, either to get this F or to gain his individual valuation of the public good. And in this way, the non-provision case is eliminated from the set of equilibria. And the second assurance payment scheme is the assurance payment mechanism. And similar payoff can be gained as the previous one. When the public good is provided, each one gets its valuation minus contribution. But when the public good is not provided, an agent who contributes high enough, which is as high as the assurance payment level, he is eligible to the assurance payment when the public good is not provided. And while those who contribute less than AP doesn't have the right to get this AP. And in this way, contributors are incentivized to contribute at level AP, and the non-provision is also eliminated. And the third assurance payment scheme, refund bonus mechanism. It is the same in the case of provision, but in the case of non-provision, each agent will get a refund bonus which is proportional to his own contribution. And so they have the incentive to contribute as much as possible toward the provision threshold of the public good. So in order to compare these three mechanisms and how they actually behave, we designed our experiments, and here is a parameter design table. We basically run 7 sessions of experiments with groups of 5, and each agent has an initial endowment of 25 experimental dollars. The provision point is set at 50 experimental dollars, and we have 2 settings of induced values. The first is homogeneous settings, and each agent values the public good at 16. And we have 2 heterogeneous induced values settings. And these numbers of induced values are designed so that they add up to 80, which is higher than the provision point. And no single agent is able to fund the public good himself. We also manipulated the level of assurance payments to see if they make any difference, but we focused on comparing the 3 assurance payment schemes when their levels of assurance payment is the same, and when they are proved in the model to have a unique provision equilibrium. And here is the table of our experiment design. And so we have 7 sessions of lab experiments, and our experiments are done with Z-tree. So we have within subject design in each session that where we change the assurance payment levels as well as the settings of individual induced values. The first 2 sessions, in the first 2 sessions, we also compare the assurance payment mechanism with the baseline mechanism. And in 3rd and 4th sessions, we compare a refund bonus mechanism with the baseline. And the 5th to 7th are dominant assurance contract mechanism comparing with the PPM mechanism. And in this way, we also have a cross between subject comparison across these 3 assurance payment schemes. So we also arrange the orders of treatments for a bit in order to somehow reduce the other effects. So we have 5 major results. The first, we are mainly talking about the provision rates. So the public good, we found, is provided significantly more frequently in the assurance payment mechanism treatments, as well as the dominant assurance contract treatments with K equals to N for both the homogeneous and heterogeneous induced value environments. But our refund bonus mechanism induces significantly lower provision rates compared with PPM. It is more clear in the graphs here, where the green line represents the provision rates of the mechanisms. So we can see it very clearly from AP10 and DAC K5 here, that the provision rates are significantly higher than the other 3 setups, treatments. And these results are also confirmed by the ratio test and rank sum tests. And in the heterogeneous environments, AP10 and DAC K5 still do better in improving provision rates. So the gray lines here are actually the average group contributions. And our findings regarding this group contributions is that higher group contributions does not necessarily indicate higher provision rates. So how do they actually generate different provision rates? Then we can then go to the reason behind this, and we thought about the group coordination problem. And so we did some analysis of how large is the proportion when the group contributions is actually equal to the provision point. And we found that in homogeneous value environment, all the studied mechanisms, APM, RBM, and DAC, coordinate significantly higher than rates of group contributions just covering costs than PPM. So the red areas here represents the proportion of group contributions exactly at 50, which is the provision point. And we found that in AP10 and RB, as well as DAC, the red areas are all significantly larger than PPM. And in the heterogeneous value environment, APM and DAC still coordinate significantly higher rates of group coordination contributions at the cost of threshold, while refund bonus mechanism fails to induce a significant difference from PPM. So the areas of RB here, refund bonus mechanism here, actually drops significantly compared with the homogeneous setups. But the red areas of AP10 and DAC are still significantly higher than PPM. So this led us to the analysis of equilibrium selection. And we categorized equilibriums into several types. The first is provision equilibrium, and the second is provision non-equilibrium. The third is non-provision equilibrium, and the fourth is non-provision non-equilibrium. And we found that APM actually induced provision equilibria as the mode of group decisions, and here at 55%, while RBM induces non-provision non-equilibria as the mode, here at 41.25%. Similar results are also evident in heterogeneous setups. And non-provision non-equilibrium and provision non-equilibrium dominate in PPM. And dominations contracts with K equals to N actually also induce provision equilibria as the mode. So it has very promising results at 100% and 89% of provision equilibrium. So how do APM and DAC induce group contribution toward the provision point? We are then interested in how they actually coordinate individual contributions. And we draw this cumulative probability graphs for different mechanisms, and found that APM and DAC coordinate individual contributions on the average cost of public good in both homogeneous and heterogeneous value environments. The orange line here and also the green line, which is covered by the orange line here, are the treatments AP and DAC-K5. They both coordinate individual contributions at 10, which is actually the average cost of the public good. It is also the similar case in the heterogeneous environment. But RBM coordinate individual contributions on the same level in the homogeneous value environment, which is represented by the purple line here, but not in the heterogeneous value environment. So we can see a much higher dispersion for the purple line in the heterogeneous environment. And we also found that coordination in APM and DAC is especially achieved by guiding individuals with values higher than average cost to contribute at the average cost. This can be seen from the graph here. This is the graph of mean contributions by induced value. And we can see that AP10 and DAC have a much flatter pattern in this graph. And we see that people with values higher than the average cost actually all contribute towards the average cost at 10. But PPM and RBM have another story. So our last result is about the social surplus generated by each assurance payment schemes. So the agent surplus here is calculated by the total assurance payment they earned, and also the value they gained from the public good minus their total contribution. And the provider surplus here is calculated by the total contribution they gathered minus the total assurance payment they actually paid. And the social surplus is a simple addition of the previous two surplus. And we found that AP10 and DAC K5 generate highest social surplus as well as agent surplus, and not as low a provider surplus in both homogeneous and heterogeneous setups, which means that it might be more attractive for contract providers to apply assurance payment mechanism or DAC when they are collecting funds. So here we come to our conclusion. In homogeneous and heterogeneous environment, APM and DAC significantly increase provision rates compared with PPM, and they do so because they have a fixed level of assurance, and they can coordinate group contributions toward the cost of public good, and they also coordinate individual contributions towards the average cost of the public good. But as for our refund bonus mechanism, with similar assurance level, it does not improve provision rates compared with VPN. And we found it does not necessarily incentivize contribution through facilitating coordination. Another simple conclusion is that APM and DAC improve coordination by providing the average cost as an explicit focal point for provision contributions. For individual contributions, especially for agents with values above the average cost. And as for a brief discussion, I would like to say that further analysis can be done to explore which kind of behavioral aspects may have caused the difference in inducing coordination in these assurance payment schemes, and whether the different assurance payment schemes elicits different behavior in these public goods schemes. And we may also measure the extent of these effects. So yeah, that is my presentation, and I'm open to questions or comments.
Hi. Yeah, I would like to ask a question. So I wonder if there's any difference in provision rates when the assurance levels are changed.
Yes, there are. Thank you for your question. There is indeed difference in the provision rates when we vary the assurance payment levels. But it is just not displayed in the results here due to time limit. As was stated in Caseman and Zubrika's paper on refund bonus mechanism, they found that actually lower refund bonus ratio or lower refund bonus induces higher provision rates, and this finding is also confirmed in our experiments. And similar results are also found in assurance payment mechanism. So actually the provision rates when the assurance payment level is above 10 is lower than when it's at 10. And the reason behind this is yet to be discovered. I think it has something concerning the behavior aspect. Thank you for your question.
There's no clear reason to explain this result.
Yeah. So yeah, I would like to further explore the data.